Core warehouse activities can be grouped into 5 categories: receiving, storage, picking, packaging and shipping, and other operations. Receiving covers unloading inbound vehicles, checking quantity and condition, and updating inventory records. Storage consists of placing goods into appropriate locations so that they are protected and can be retrieved efficiently. Picking retrieves the specific items and quantities needed to fill customer orders. It is often the most labor-intensive activity. Packaging and shipping prepare goods for transport to the next destination, including choosing containers, labeling and loading vehicles. Other operations include returns processing, kitting, light assembly and quality inspection. In a typical day at a 3PL warehouse in Binh Duong, trucks arrive from manufacturers in the morning, receiving. Goods are put away into racks, storage. Pickers assemble store orders in the afternoon, picking. Packers prepare pallets and cartons with shipping labels, packaging and shipping. And a separate area handles customer returns, other operations. Example. In a typical day at a 3PL warehouse in Binh Duong, trucks from manufacturers arrive in the morning, receiving. Goods are put away to assigned rack locations, storage. Orders for supermarkets are collected in the afternoon, picking. Pallets and cartons are stretch-wrapped and labeled, packaging and shipping. And a separate area handles returns of damaged packaging from stores, other operations. Receiving is the first warehouse activity and has a strong impact on all others. During receiving, inbound shipments are unloaded safely, counted and inspected, and compared with purchase orders and transport documents. Any visible damage or quantity discrepancies are recorded so that claims can be filed if necessary. Pallets are labeled or tagged so that they can be tracked in the warehouse management system. Clear instructions to suppliers about pallet size, packaging standards and delivery time windows help make receiving fast and accurate. For example, a supermarket distribution center may require all suppliers to use standard 1.2 meters pallets and to label each pallet with a barcode that includes the purchase order number. When a truck arrives at the dock, staff scan the barcodes, count the pallets and quickly identify where the goods should be stored. Example. When a supplier delivers snack foods to a supermarket distribution center, the truck must arrive within a pre-booked time window. Warehouse staff open the doors carefully, check that the security seal is intact, count pallets, sample a few cartons to check expiry dates and visual condition, and scan pallet labels into the system. Only after these checks are complete are pallets moved to the staging area and then onto storage. Storage is the most visible and often the most space-consuming function in a warehouse. The goal is to use cubic space efficiently while protecting products and keeping them accessible for picking. Options include floor stacking on pallets, low or high bay pallet racks, movable racks, flow racks and automated systems. The choice depends on product characteristics such as weight, fragility, value and demand frequency. Fast-moving, low-value items may be stored on the floor or in low racks near the shipping area, while slow-moving, high-value items may be stored in secure high-bay racks or automated systems further from the docks. In a food and beverage warehouse, heavy and sturdy items like bottled water may be floor-stacked in blocks, while more fragile items like glass bottles of sauce are placed on racks to keep stacking pressure low and reduce breakage. Example. In a beverage warehouse, heavy pallets of bottled water may be stored in block stacks on the floor near the shipping area because they move quickly and are robust, while lighter cartons of glass bottled soft drinks are stored on pallet racks with just 2 or 3 layers per pallet position to avoid breakage. Both products are in the same building, but their storage methods differ to reflect their physical characteristics and sales patterns. The picture on this slide shows pallets placed directly on the floor. Floor stacking is simple and involves relatively low equipment cost. It is suitable for uniform, sturdy items such as bags of rice, cartons of canned drinks or cement that can tolerate stacking several layers high. However, if stacks become too high or if products are fragile, floor stacking can crush lower layers and make it difficult to reach older stock first. Ignoring, "Do not stack" markings on cartons can lead to product damage and safety hazards for workers. In some small warehouses in Vietnam, Televisions or refrigerators are sometimes stacked in ways that bend packaging or even damage the products inside. In contrast, professional 3P warehouses set maximum stack heights and use corner posts or racks to protect products from excessive pressure. Example: a small local distributor might stack cartons of instant noodles 4 or 5 layers high directly on the floor. For strong cartons this is acceptable. But when they try the same method with flimsy boxes of biscuits, the bottom layers collapse and products are crushed. After repeated damage, the distributor learns to limit the stack height for fragile items and invests in simple shelving for those products instead of floor stacking. This slide shows low-height wide aisle rack storage. Wide aisle racking allows standard forklifts to maneuver easily between racks, providing good accessibility to every pallet location. Low-height racks are appropriate when ceiling height is limited, when products are heavy and difficult to raise very high, or when capital budgets for specialized equipment are constrained. The trade-off is that vertical space is not fully used, so more floor area is needed to store the same amount of inventory compared with high-bay systems. A regional wholesaler serving only a few provinces may find wide-aisle low-bay racking sufficient. As demand grows and land prices in urban areas increase, the company may later invest in taller racks or narrower aisles to increase capacity without buying more land. Example: a regional wholesaler with modest volumes of electronics and household goods installs standard pallet racks with wide aisles so that common counterbalance forklifts can be used. Forklift drivers can easily turn and pass each other in the aisles, reducing the chance of collision. As the wholesaler grows and runs out of space, it later considers converting some wide aisles to narrower ones and purchasing reach trucks to increase capacity without expanding the building footprint. The next slide shows high-bay narrow aisle racks. High-bay narrow aisle systems are designed to maximize storage density by using much of the building height and reducing aisle width. Specialized equipment such as reach trucks or very narrow aisle (VNA) trucks operates in these aisles. This configuration increases pallet positions within the same building footprint, which is attractive when land is expensive or when a firm wants to centralize inventory in one large facility. The trade-offs are higher initial investment, greater dependence on specialized equipment, and the need for strict safety and maintenance practices. A pharmaceutical distribution center near Hanoi might use high-bay narrow aisle racking to store temperature-controlled products that require expensive refrigerated space. By going upwards rather than outwards, the center reduces the cost per pallet of refrigerated construction and operation. Example: a pharmaceutical warehouse near Hanoi stores pallets of boxed medicines in high-bay racks that rise almost to the ceiling, with very narrow aisles served by specialized VNA trucks. Temperature control systems keep the whole volume within strict limits. Because the products are high value and relatively small, the cost of the racking and equipment is justified by the amount of inventory stored and the high rent of temperature-controlled space. Very high-bay warehouses extend the high-bay concept further and are often combined with automation. Racks may reach 20 meters or more, and automated storage and retrieval machines move along aisles to place and retrieve pallets under computer control. These systems provide very high storage density and precise inventory control with relatively low labor in the storage area. However, they require large upfront investment and are best suited to products whose size and handling requirements will remain stable for many years. In Europe, some beverage companies operate fully automated high-bay warehouses where thousands of pallets of bottled drinks are stacked more than 25 meters high. In Vietnam, similar concepts are starting to appear in cold storage facilities serving seafood exporters and modern retailers. Example: a frozen seafood exporter builds a very high-bay cold store where automated cranes move pallets of frozen shrimp to and from deep racks. Pallets arriving from processing plants are quickly scanned and placed into storage by the system. When an export order for a particular customer and country is received, the control software retrieves exactly the right pallets following FIFO rules, minimizing door opening time and keeping a precise record of batch locations for traceability. Movable rack systems, like the one pictured in a library, show how storage density can be increased by eliminating fixed aisles. Shelving units are mounted on rails. Only one or two aisles are open at any time, while others are pushed together. When a worker needs access to a particular section, they move the shelves to open the appropriate aisle. This design greatly increases storage capacity on a given floor area but reduces immediate access to all locations at once. It is therefore suitable for slow-moving items or archives where access is infrequent but secure. Dense storage is important. A company in Vietnam storing engineering drawings, tax records or rarely used spare parts might use mobile shelving to keep these items safe and organized without renting additional warehouse space. Example: a telecom company keeps thousands of archived contract files and technical drawings in a compact mobile shelving room. Staff open one aisle at a time to retrieve rarely used folders while the rest of the shelves remain closed together. Without movable racks, the company would need a much larger room or a separate warehouse just to hold the same volume of paper records. Rolling or flow racks, shown on this slide, are designed for small or medium-sized items that move regularly. Containers or cartons are loaded at the rear of the rack and move forward by gravity along inclined rollers. When a picker removes the front carton, the next one automatically rolls into position. This supports first in, first out FIFO rotation and reduces walking and reaching for pickers. Flow racks are common in assembly plants, spare parts warehouses and some grocery distribution centers. In a motorbike assembly plant in Vietnam, screws, bolts and plastic clips can be stored in flow racks along the production line. As assemblers take parts from the front, new containers are inserted at the back, ensuring older stock is used first and reducing the risk of missing components. Example: in an automotive parts warehouse supplying a repair workshop network, brake pads, filters and spark plugs are stored in carton flow racks. Mechanics or pickers load new cartons from the rear, and older cartons roll to the front. When a repair order arrives, the picker simply takes parts from the front lane, ensuring that the oldest stock is used first and reducing the risk of having obsolete items hidden at the back of static shelves. Automated storage and retrieval systems, AS, as shown here, use machines to store and retrieve loads in high bay racks under computer control. Cranes or shuttles move along aisles, lift pallets or totes to the required height and place them into or remove them from specific locations. The warehouse management system directs every movement and records inventory positions precisely. Advantages include high storage density, accurate and timely stock information, reduced labor in the storage area and improved safety. Disadvantages include high capital cost, dependence on reliable software and hardware and less flexibility for irregularly shaped products. A large frozen food warehouse near Ho Chi Minh City might adopt AS so that people spend less time working in the cold environment, while conveyors and cranes handle the majority of pallet movements inside the freezer. Example: a large beverage producer near Ho Chi Minh City uses an AS system for finished goods storage. Forklifts unload full pallets from the production line onto conveyors, and from that point on, cranes automatically put pallets away into high bay racks. When store orders come in, the system retrieves the right mix of SKUs and sends them to a staging area, where staff build outbound truckloads. The number of forklift movements inside the rack area is almost zero, improving both safety and accuracy. Vertical carousels, shown in this slide, are another form of automated storage for small, often high-value items. Shelves rotate up and down inside an enclosed cabinet, bringing the required tray to an access opening at ergonomic height. This design saves floor space by using vertical height and can greatly reduce walking time. It also allows tight control of access, which is useful for expensive or sensitive items. Integrated barcode or RFID scanning provides accurate transaction records. Hospitals in Vietnam could use vertical carousels to store medicines or surgical instruments, ensuring that items are secure, stored in controlled conditions and retrieved quickly when needed. Example: a hospital pharmacy in Da Nang could store high-value medicines and implants in vertical carousels. When a nurse requests a specific item, the pharmacist enters the code, and the carousel brings the tray with that medicine down to waist level. Access is logged automatically. Expiry dates are monitored in the software. And stock differences are easier to detect than in traditional cabinets. Picking strategies define how people or machines move relative to the goods. In a goods-to-picker system, products are brought to stationary pickers using conveyors. Carousels are mobile robots. This reduces walking and can achieve very high productivity. But it requires substantial investment in automation and software. In a picker-to-goods system, pickers travel through the warehouse with trolleys or forklifts to collect items from storage locations. This approach is more flexible and cheaper to implement but usually involves more travel time and physical effort. An e-commerce fulfillment center handling thousands of small orders per day may choose goods-to-picker technology such as shuttle systems or robots. Whereas a smaller wholesaler serving only a few large orders per day may rely on traditional picker-to-goods operations. Example: a medium-sized wholesaler of office supplies may continue using picker-to-goods methods because it handles a few hundred orders per day with many cartons per order. In contrast, a large e-commerce player shipping tens of thousands of small, varied orders each day may invest in goods-to-picker systems with conveyors and automated shuttles so that workers can stand at fixed stations while products flow to them. The Kiva robot system, now part of Amazon Robotics, is an example of a goods-to-picker strategy. Robots move beneath pods holding shelves of products, lift them and carry them to pick stations. Human pickers stand at these stations and remove the required items from the pods. When a pod is finished, robots return it to storage and bring another. The warehouse management system decides which pod goes where and in what sequence. This arrangement drastically reduces walking and allows dynamic rearrangement of inventory so that fast-moving products are stored closer to pick stations. If a Vietnamese e-commerce company were to adopt similar robots, it would need a very flat floor, reliable wireless networking and robust software to manage robot traffic safely while coordinating thousands of picks each hour. Example: imagine an e-commerce fulfillment center in Binh Duong adopting mobile robots similar to Kiva. When a customer orders a phone case and a power bank, robots underneath storage pods bring the relevant shelves to a picker, who selects the items and confirms them by scanning. Robots then return the pods to storage and move on to the next task, keeping human walking distance to a minimum even though tens of thousands of SKUs are stored in the building. Horizontal carousels, pictured here, are loops of rotating shelves that bring products to the picker. When the system receives an order, it rotates the shelves so that the required bin appears at the pick face. Several carousels can work together at one station, with software sequencing their movement so that while the picker is working at one carousel, others are moving to their next positions. Horizontal carousels are particularly effective for medium-speed items, providing high throughput in a relatively compact footprint. A spare parts warehouse for electronics might store resistors, capacitors and small components in horizontal carousels, allowing technicians to assemble repair kits quickly without walking long distances through shelving. Example: a spare parts warehouse for photocopiers might store small components, rollers, gears and sensors, in several horizontal carousels. When a service center places an order, the system sequences carousel rotations so that by the time the picker has finished picking from one carousel, the next required bin on another carousel is already in position, creating a continuous picking rhythm with minimal waiting. Picker-to-goods systems require people to travel to storage locations. As shown in this slide, pickers receive instructions via paper or electronic devices and move through aisles with trolleys or forklifts. They locate the correct slot, take the required quantity and then move on to the next location. Productivity depends heavily on layout, routing, slotting decisions and the chosen picking method. Clear signage, well-maintained equipment and good lighting help reduce errors and fatigue. In many Vietnamese warehouses, especially smaller ones, picker-to-goods methods are still standard because they require modest investment and can easily adapt when the product range changes. Example: in a traditional picker-to-goods warehouse supplying mini-marts in Ho Chi Minh City, Each picker pushes a trolley with a tablet that lists the items needed for one store. The picker walks through the aisles, collects cases of instant noodles, bottled water and snacks, and returns to the dock. Because stores often order similar items, careful route planning and good slotting decisions can significantly reduce the total walking distance for each trolley tour. Within a picker-to-goods environment, several picking methods can be used to manage travel and sorting work. Pick by order completes one customer order at a time and is simple to manage but may involve significant walking for small orders. Cluster picking lets a picker collect items for several orders in one tour using multiple bins or compartments. Batch picking collects common items for many orders in one pass and sorts them later in a separate area. Zone picking divides the warehouse into zones. Each picker is responsible for one zone, and orders move from zone to zone until complete. An online grocery service in Ho Chi Minh City might use batch or zone picking. Many orders contain staples such as rice, cooking oil and fish sauce, so collecting those items in batches or by zone can significantly reduce travel distance compared with filling each order separately from start to finish. Example: an online grocery service could use zone picking by assigning one group of workers to the chilled area, meat, dairy, and another group to the ambient area, rice, snacks, canned food. Each group picks only the items from its zone for many orders, and the orders are merged at a consolidation station. This avoids repeated trips in and out of cold rooms and allows pickers to become very familiar with the products in their own zone. Picking techniques refer to the tools used to communicate picking instructions and confirm that picks are correct. Paper lists are the simplest method but are prone to loss and manual errors. Label picking uses pre-printed labels for each order line, as items are picked. Labels are attached to containers, making it easier to track which items belong to which orders. Barcode picking uses handheld terminals or mounted screens to display instructions. Pickers confirm each pick by scanning the product's barcode, and the system updates inventory records instantly. More advanced techniques include voice picking and light picking, which reduce the need to look at screens or paper. A warehouse upgrading from paper to barcode picking in Vietnam would invest in handheld scanners and a wireless network. Pickers would learn to follow on-screen instructions and scan each item, greatly reducing missed picks and giving managers real-time visibility of progress. Example: a warehouse switching from paper lists to barcode picking equips each picker with a handheld terminal. When a store order for 20 SKUs arrives, the device shows the optimal path and prompts the picker to scan each location and product. If the wrong barcode is scanned, the terminal beeps and displays an error message, preventing mistakes before the goods leave the shelf. Over a few months, picking errors drop sharply and inventory accuracy improves. The photo on this slide shows cluster picking using a paper list. Several orders are being filled simultaneously, each assigned to a separate box or compartment on the trolley. This method reduces travel distance because the picker can serve many orders in one tour instead of walking the same aisle repeatedly. However, managing multiple orders with paper also increases the risk of placing items in the wrong box or overlooking a line on the list, especially when the picker is tired or under time pressure. A small apparel warehouse in Vietnam might use cluster picking with color-coded boxes to separate orders for different retail stores. Simple visual controls like color coding can help reduce errors even without advanced IT systems. Example: in a small footwear warehouse, a worker may push a trolley carrying 10 plastic totes, each tote representing one store order. Using a paper list, the picker stops at a shelf of sports shoes and needs to remember how many pairs to place into each tote. Under time pressure, it is easy to misplace a pair, so the supervisor later introduces simple colored labels or dividers inside the trolley to make it clearer which items belong to which order. Label picking, illustrated by the Land's End example, uses labels to link products and customer orders clearly. Each order has a label containing customer information and order details, and each line item has a corresponding label. When the picker selects an item, the appropriate label is attached to its package or to the container holding it. At the packing station, workers can confirm quickly that every label, and therefore every order line, has been filled. This reduces the need to recount items and speeds up verification. An online clothing retailer can print labels showing order numbers and product codes. Attach them to picked garments and then match them efficiently with invoices and shipping documents in the packing area. Example: an apparel retailer printing online orders in advance can produce one label per garment. As the picker takes a specific T-shirt from the rack, they immediately attach the correct order label to its plastic bag. At the packing table, staff simply match labeled bags with the corresponding invoices and shipping labels, reducing the need to reread product codes or sizes and cutting down on wrong size shipments to customers. Barcode picking adds scanning technology to guide and verify picks. Pickers carry handheld scanners or use devices mounted on forklifts. The system tells them which location to go to and what quantity to pick. When they arrive, they scan the location or the product barcode. If the code does not match the expected item, the device warns them. After the correct quantity is confirmed, the inventory system updates stock levels instantly. This improves accuracy, provides real-time visibility and supports productivity analysis by recording how long tasks take. A beverage warehouse that previously relied on manual records might move to barcode picking and a simple warehouse management system. As a result, inventory discrepancies shrink, and managers can see which SKUs or aisles cause the most picking delays. Example: a beverage warehouse introduces barcode picking for its top 500 SKUs. Forklift drivers receive tasks on mounted terminals. Drive to the indicated rack and scan both the rack label and a case barcode before loading it. If the driver accidentally scans the wrong flavor or bottle size, the system gives an error sound and message. Over time, the number of wrong product deliveries to supermarkets drops, and customer complaint data confirm the improvement. Voice picking uses spoken instructions and voice responses instead of screens or paper. Pickers wear a headset connected to a small terminal. The system speaks the next location and quantity, and the picker confirms by speaking a check digit or count. Because their eyes and hands are free, workers can focus on driving or handling cartons safely. Voice systems are especially useful in environments where it is difficult to handle paper or terminals, such as cold storage warehouses or very dusty environments. A chilled food distribution center in Vietnam could adopt voice picking so that workers wearing gloves in refrigerated rooms do not have to handle paper lists or touchscreens, reducing both time and the risk of dropping devices. Example: a cold storage operator in the Mekong Delta adopts voice picking for frozen seafood. Pickers wearing headsets hear instructions such as, aisle 3, bay 5, pick 4 cartons, and confirm by speaking the check digits printed on the rack label. Because their hands are free and they do not have to look at a screen in the cold, they move faster and make fewer errors, even while wearing thick gloves and jackets. Light-directed picking uses lights and numeric displays mounted at storage locations to guide pickers. When an order is released, lights turn on at the bins where items are needed, and small displays show the quantity to pick. The picker walks along the aisle, stops at illuminated locations, picks the displayed quantity and presses a button to confirm. This approach is very fast and intuitive, making it suitable for high volume, small item operations such as e-commerce or spare parts fulfillment. Because the system clearly shows where to pick and how much, error rates can be very low. A company selling mobile phone accessories online could install light picking in a compact pick module containing thousands of SKUs. During peak times such as 11 to 11 or 12 to 12 campaigns, light-directed picking would help maintain speed and accuracy under heavy order pressure. Example: an e-commerce company selling phone accessories sets up a pick-to-light system in a compact area where its fastest-moving SKUs are stored. When 50 customer orders are released, lights on hundreds of small bins illuminate with the quantities required. One picker walks the aisle and quickly picks to the lit bins, pressing each button to confirm. This method allows the company to process flash sale campaigns with high accuracy despite intense time pressure. After picking, Goods must be packed and shipped. This slide summarizes those activities. Packers choose the right size and type of carton or packaging material to protect the items during handling and transport. They add internal protection such as paper or bubble wrap where necessary and close the package securely. Shipping staff then create shipping labels and documents, assign each shipment to an appropriate carrier and service level, and move parcels to the correct staging area for loading. Choices about packaging and carrier influence not only cost but also damage rates and transit time. When a customer in Da Nang orders a laptop online, the fulfillment center must place the laptop in a sturdy box. Add sufficient cushioning. Include documents such as invoices and warranty cards. Attach the correct address label and then select a carrier capable of providing reliable, traceable delivery. Example: when a customer orders a ceramic tea set from an online marketplace, the warehouse must choose a strong double-wall carton, wrap each cup and the teapot individually, fill empty space with cushioning material and label the box as fragile. The shipping team then selects a carrier that offers careful handling and tracking, rather than the absolute cheapest option, because the cost of replacing broken items and disappointing the customer is much higher than a small difference in freight rates. The picture of package preparation on this slide illustrates how much care is required at this stage. Poor packaging can undo the work of the whole warehouse. A fragile item such as glassware or electronics may arrive broken if the carton is too thin, if there is insufficient internal cushioning, or if packages are not labeled so that handlers know to keep them upright. On the other hand, excessive packaging increases material cost and creates waste. Good practice finds a balance. Enough protection to ensure product quality at delivery while controlling cost and environmental impact. Many Vietnamese customers have experienced receiving online orders where shampoo bottles leaked or biscuit tins were crushed. Such incidents often trace back to poor packaging design or rushed work in the warehouse. Example: a cosmetics distributor that frequently received leakage complaints redesigned its packing process. Instead of simply placing bottles upright in a carton, packers now seal each cap with tape, place bottles in individual compartments and add a plastic bag around the whole group before closing the outer box. After implementing this more careful packing method, the number of damaged on arrival reports from retailers fell sharply. The shipping area, shown here, is the final checkpoint inside the warehouse before goods enter the transport system. Packages are sorted and staged by route, carrier, customer or departure time. Clear organization prevents the wrong parcels from being loaded onto a truck and helps drivers depart on time. Dock doors must be scheduled carefully so that trucks can arrive, load and leave without long waits. In busy seasons, staging areas can become crowded, creating risks of damage and missed-shipment if space and processes are inadequate. In an express parcel hub in Ho Chi Minh City, vehicles from different districts arrive every evening. Workers unload bags of parcels, sort them by destination region and reload them onto long-distance trucks. Well-designed staging and clear labeling make the difference between smooth overnight operations and chaotic delays. Example: in a regional hub for an express parcel company, parcels for northern provinces are staged on one side of the dock and parcels for southern provinces on the other. Each staging lane corresponds to a specific outbound truck and departure time. As departure time approaches, staff scan the staged parcels and load them in sequence so that the last delivery stop is placed closest to the truck's door, saving unloading time at each destination. Many warehouses perform additional operations beyond the basic flow from receiving to shipping. These include processing returns and warranty claims, inspecting goods, repairing or refurbishing items, performing kitting or light assembly, repacking goods into promotional bundles and applying special labels required by different markets. Such activities add value by tailoring products to customer requirements and by extending product life through repair or refurbishment. They also allow manufacturers to postpone final product configuration until closer to the point of sale, which can reduce inventory of finished variants. For example, a warehouse might receive standard printers and then, based on customer orders, add the appropriate power cord, Manual in the local language and starter cartridge before shipping them to retailers or directly to end users. Example. A smartphone brand operates a central returns center in Bin Duong. Defective phones from retail shops are sent there, where technicians diagnose the fault. Some phones are repaired and returned to stock as refurbished units. Some are scrapped for spare parts. And some are forwarded to the original manufacturer for investigation. At the same site, staff build accessory kits, charger, cable, earphones, manuals, for different markets and languages using components stored in the warehouse. The photo on this slide shows kitting or light assembly work in progress. Workers sit at tables combining parts from different bins into kits, checking that each kit contains the correct components and packaging them for shipment. Quality control at this stage is crucial. A missing screw or cable can make the entire kit unusable for the customer. Clear work instructions, visual aids and simple checklists help maintain accuracy, while coordination with inventory management ensures that component stocks are replenished in time. Flat pack furniture sold in Vietnam often reaches customers as a kit of boards, screws and tools packaged together. Many of those kits are assembled and checked in warehouses similar to the one shown here rather than at the main manufacturing site. Example. A furniture importer receives flat-packed wardrobes from overseas suppliers. In a kitting area inside the warehouse, workers open selected cartons, add locally sourced screws, wall anchors and Vietnamese language instructions, and then reseal the carton with a new label. Retail stores receive a complete kit that is ready for end customers to assemble at home without needing extra hardware or translated manuals. Warehouse